Okay, in the circuit shown in the figure, C1, C2, and C3, the applied potential difference between points A and B is VAB 61.5 volt. Calculate the effective capacitance between point A and B. The charge on each capacitor, and potential difference between point A and D. Okay, good. All right. Okay. If we see circuits like this, it's better if we draw it again. That means we because this one is curved up, you can see this circuit is curved up. So you might not see the real structure of the circuit. Yeah. So it's better for you to draw it out, yeah, to lay it out so that you can see the connections, series or parallel much clearly, yeah, much clearer. Okay, so I redraw this whole circuit again. Okay, I redraw it. Okay, so this is the actual one. Okay, let me redraw it. Yeah, and this is the capacitor. Yeah, like that. So this is point A. Okay, point A. This is point B. Do you agree with me? Do you agree with me? So at the center, what point is this? This is point D, isn't it? And then this should be the C1. This use other color. This one should be the C1. This one is the C2. This one is the C3. Do you agree with me? Yeah, I just lay it out. And this is the actual structure. So here we can see even clearer that C1 and C2, they are parallel to each other. And then the combination of C1 and C2, the combination of these is in series with C3. Okay, it's in series with C3. So it's better you draw it like this. Yeah, it's the same. This whole thing is the same as this one. Okay, it's the same. Okay, and then here I give you the value. I think it's better you just write it on the diagram itself. This is 2 microfarad. And then C2 is 4 microfarad. Okay, 4 microfarad. C3 is 9 microfarad. 9 microfarad. Okay, and then he gives you that the applied potential difference between A and B is VAB is 61.5 volt. So that means excuse me, that means between here applied potential difference, that means maybe it connect to a battery. You understand? Maybe it connect to a battery. Applied potential difference, it connect to a battery. So the VAB, voltage across, voltage across AB is 61.5 volt. This is actually the V total. Okay, maybe this 2 point AB, they connect to an external battery of 61.5 volt. That is actually the V total. Or we can also say this VAB is actually the hold on a second. Later I will tell you. Yeah, later I will tell you. Okay. If you look at question A, he asks for effective capacitance. Normally this is the first step. Normally ask for the effective capacitance. Sometimes he use the word equivalent. You can see sometimes he use the word equivalent. Effective, equivalent is the same. Okay, it's the total capacitance. Okay, equivalent capacitance is the same as effective capacitance. Yeah. Between A and B, so we can say this is CAB also lah. You want to say, or you can just combine everything. This is a C1, C2, C3. So you can say this as C123. Whatever name you want to put it, whatever name you want to put it. You want to put it as C123 also can. You want to put CAB also can. C equivalent also can. C total also, you want to put it as C total also can lah. Whatever name you want to put. So that is what I mean. That is what I mean also by the VAB just now. You want to put it as V123 or V total also can, yeah. Whatever. Combine everything. Okay. All right. Let us not waste our time. Okay. So let us find the question A. Question A. Okay. Question A. So between we can see this. C1 and C2, they are in parallel, isn't it? Yeah, they are parallel. So between C1 and C2, okay, they are parallel. Okay, because they are both leg connected. See that? They are both leg connected. So what's the formula for finding capacitance in parallel combination? We know that in parallel combination, capacitor becomes stronger. So it must be plus, yeah, C1 plus C2, isn't it? Capacitor in parallel becomes stronger. That means the capacitor must plus. Okay. So let us find it. Yeah, C12 is equal to C1 plus C2. Capacitor becomes stronger. Yeah, in parallel. Okay, so this is 2 micro. 2 micro plus 4 micro. So I got 6 microfarad. I got 6 microfarad. After that, between the C12 and C3, they combine as series, isn't it? Why? Because they only connect with one leg. They only connect with one leg. Okay, C12 and C3 they only connect with one leg. The other leg connect to the power supply. The other leg connect to power supply. They only between C12 and C3 only connect with one leg. Okay, this is how I look. Just now C1 and C2 they connect with two legs. Yeah, but between C12 and C3 only connect with one legs. That's why I say is series. Okay, and series the capacitor become smaller. Yeah, become smaller. Series becomes smaller, so it's a 1 over C. Yeah, 1 over C. So let's find out the C123. You can also write it. C123 is 1 over C12 plus 1 over C3. Okay. C12 is 6 micro plus C12 is 6 micro, and then C3 is 9 micro. Okay, so let's calculate. Yeah, 1 over 6 plus 1 over 9. Okay, so is 5 over 18 micro. Okay, is this the answer? Is this the answer? No, this is not the final capacitance yet. No, this is just 1 over C123. So you haven't invert. Many students mistake in this part. They forget to invert the thing. They forget to invert the thing. Don't make such a mistake. Yeah, don't make such a mistake. So I invert it. And the answer I get is actually 3.6 microfarad. That's the answer. That's the answer. Yeah, that's the effective or can say as equivalent. That's the C total also, or C123. Whatever name you want to put it. Or you want to put it as CAB also can. Yeah. So is the answer correct? Yes, 3.6 microfarad. That's correct. Yeah, that's correct. Okay, I got it. Now I want to find. Okay, so I want to find the charge on each capacitor. Charge on each capacitor. So that means I need to find what? I need to find this question. I want to find the charge on each capacitor. That means I want to find Q1, I want to find Q2, I want to find Q3. Yeah, I need to find the charge in each capacitor. I need to find this Q1, I need to find Q2, I need to find the Q3, yeah, stored in each capacitor. So how I'm going to find it? All right, so let's do it. Important thing is you must get the equivalent capacitance first. This is the most important thing. From there you can work it out, yeah, the rest. Okay, let's move on to question B. Question B, want to find the charge. Okay, one thing is we already know about the total voltage. Total voltage is 61.5 volt. The total voltage. We also know the total capacitance, 3.6. What is missing? The total charge. We haven't get the total charge. Use the formula Q equal to CV. Okay, from there we can get the total charge. As I told you in the example before, I told you already before. We always find the total capacitance first. After we get the total capacitance, we can get the total voltage or total charge. And from there, after we get the total charge or total voltage, we can find each individual Q1, each individual capacitor charge, Q1, Q2, Q3, Q4, or you want to find the voltage also can. That's the flow of work. That's the flow of work, okay? The total capacitance is always the first step. The next step is to find the total charge or total voltage. Okay, and then this is the last part. Okay, I hope you know the flow of work. Okay, so I got the total capacitance already. Now I want to find the total charge. So where is it? Total charge, this is the total charge, total capacitance, total voltage. Okay, so let's find it. So the total charge. Oh, why I'm using green? Use the blue color. So total capacitance is 3.6 microfarad, and voltage is 61.5 volts. Okay, so what do I get? Yes, I got 221.4 microcoulomb. Why do I have a micro here? Why not just coulomb? Why not the unit just coulomb? It's wrong. Yeah. Because why? Because your farad got micro. Because it's microfarad, not just farad. It's microfarad. That's why your coulomb is microcoulomb, not just coulomb. Understand? Be careful. Your unit. This one is microfarad, so this one is still microcoulomb. This micro is like exponent -6. Exponent -6 got some certain value inside. So you must be careful. Okay. So that's my total charge. I need to find the charge on each capacitor. Okay, I need to find the charge on each capacitor. How am I going to do it? Very simple. From there you work. From there you see the let's say like series circuit. From there, after you get the total charge, from there you see the relationship. Total charge is, if in series circuit, the total charge is the same for all. You see that? Q total is Q1 equal to Q2, Q3. If V total is plus all the voltage together, yeah. From there you work out the relationship. Refer back to my notes. Yeah. You must know this. You must know this thing first. Like in series, this thing is important. Like in series, the total charge is the same as the charge on each capacitor. Yeah, same as the charge on each capacitor. Why is it? I already tell you why. The reason in my concept videos, in my lecture video, I already explained about this. I'm not going to explain again. Okay, whatever thing is because it's only have one circuit. So the current can only travel in one circuit. So all you can say charge is like current. So the current is the same for all capacitor. So the charge also the same for all capacitor. That's the simplest explanation. Okay, charge is the same for all capacitor. Like in parallel, the charge branches out to different branches. So different capacitor has different charge. Different capacitor has different charge. But this one, in single circuit, series circuit, the charge, it only has a single circuit. So the charge can only travel in a single circuit, so the charge is the same for all capacitor. Whereas this one, parallel, the charge is different for different capacitor. So for parallel circuit, the charge is total charge is the added up Q1 plus Q2 plus Q3. Okay. So alright, in series circuit, the charge is the same for all, but the voltage is added up, V1 plus V2 plus V3. So the total voltage is we add up all the voltage, V1 plus V2 plus V3. That's series. Okay. But for parallel circuit, since this capacitor, they connected in parallel, so they share the same voltage because they share the two same point. They share the two same point with the battery. So they all have the same voltage as the total voltage. So V total equal to V1 equal to V2 equal to V3. So go back to your basics. Know the relationship very well. Okay, know about this series and parallel, the relationship of the charge, voltage, and the capacitance. Yeah, very well. This is very important. Okay, so go back to our questions. We want to find the charge in each capacitor. So what I can say from here is we got the total charge already. Got the total charge. Okay, total charge. So the total charge, yeah, you see this 1 2 is series with 3, isn't it? 1 2 is series with 3. So series circuit. Okay, go back to here. Okay, this C12. Okay, here again. Let me draw it out. Yeah, C12 and C3. Yeah, C12 means after C1 and C2 combine. Yeah, C12 and C3, they are series, right? I just want to write it out again. C12 and C3, they are series. So what I can say is, okay, if series, they have the same charge, isn't it? They have the same charge. Series, they have the same charge. Okay, so I can say that this Q total is the same as Q12, the same as Q3. Because they are series. Understand? They are series. So they have the same charge. Q total is equal to Q12 equal to Q3. Okay. Now, just now Q total is 221. Okay. So equal to, I already got the value also just now, isn't it? 221.4 microcoulomb. So I already got the first answer, Q3. Q3 is 221.4 microcoulomb. So I got my first answer over here. Is that correct, my Q3? My Q3 is I can say this as 2. Wait, I can put this as, this is 221. Micro is exponent -6. So this one becomes what? Becomes 2.214 exponent -4 microcoulomb. Is that correct? Yes, that's the answer. You see that? 2.21 exponent -4 coulomb. That's correct. That's Q3. I got my first charge. Now, how about Q1 and Q2? How am I going to do it? Q1 and Q2. All right. From here, I got Q12 is 221.4 microcoulomb. Okay, 221.4 microcoulomb. So I know that the total charge between Q1 and Q2 is 221.4 microcoulomb. But this Q1 and Q2, what I can say, they are parallel. C1 and C2, they are parallel. Yeah, I should think I should. Okay, now go back to here. go back to C1 and C2. They are parallel. Understand? Now we go to parallel. C1 and C2, they are parallel, isn't it? Parallel is I got the Q12 is 221.4 microcoulomb. Okay, the total charge between C1 and C2 is 221.4 microcoulomb. That means the whole thing here is 221.4 microcoulomb. Okay, but C1 and C2, they are parallel. Parallel, what is mean by parallel? Parallel means that the charge is added up. Charge is added up. Q1 plus Q2 plus Q3. Understand? That means what I can say is this Q12 is actually Q1 plus Q2. Because parallel, the charge is added up. Parallel, the charge is plus plus plus. Understand? If parallel, only the voltage is equal. Only voltage is equal, but the charge is plus plus plus. So Q12 is Q1 plus Q2. Okay, so this is also equal to 221.4 microcoulomb. Okay, but how to find Q1 and Q2? Oh, I got one problems here. How to find Q1 and Q2 separately? Okay, so I cannot go on from here. I need to find another way. In parallel, what are the relationship for voltage? If charge cannot work out, then I need to think about other things. I need to think about other things like, let's say like, if charge cannot work out, I need to think about the voltage, isn't it? Since the charge cannot work out from here, I cannot go on from here. I don't know what is Q1, what is Q2. So I cannot move on from charge. I need to think about the voltage. Okay, since I already have a charge, I have Q12. So I need to find out what is V12, isn't it? Voltage. So first you find V12 first. You find V12. Can I find V12? Do you think I can find V12? Of course you can. Because I need to have the C12. First I need to have C12. Then I can find V12. Because I already have Q12. Because I can use the relationship of, I can use the relationship of Q equal to CV. Since I can do the Q total equal to C total equal to V total, I also can do something like Q12, C12, V12, isn't it? So C12 I also have. You see, I got the C12 is 6 microfarad. 6 microfarad. I put it over here. I can find the V12. Okay, let's do it. Yeah. So this is 221.4 microcoulomb and equal to C12. C12 is 6 microfarad. 6 microfarad, and then I can find my V12. Okay. So see, here I have a micro. They can be cut off. They can cut off. I can cut off my micro. Okay. I can cut off my micro. And now 221.4 divided by 6. I got the answer. Yes. I got the V12 as 36.9 volt. 36.9 volt. Okay. So the micro can be cut off. Yeah. This micro can be cut off. So I divide this one by 6. I got 36.9 volt. Okay. What is the use of V12? Good. What is the use of V12? Okay, if you look at our parallel circuit, the voltage of each capacitor is the same. The voltage of each capacitor is the same because they share the same connection. Okay, V1 equal to V2 equal to V3. V total equal to V1 equal to V2 equal to V3. So they share the same voltage. So I can say from here, I got the V12. I can get a V12. So the V12 is the same voltage. So V12 equal to V1 equal to V2. Okay. So V12 equal to V1 equal to V2. V12 equal to V1 equal to V2 because they are the parallel circuit. Parallel circuit, they have the same voltage. V12 is V1 and also equal to V2. I got the voltage already, so this one is equal to 36.9 volt. Okay, now I got this. I got V1 and V2. The voltage is 36.9 volt. And do you think this V1 and V2 will help us? Of course, it helps us to find the charge 1 and charge 2. Okay, how is it going to help? How is it going to help? You can also use back the formula Q equal to CV, to find Q1 and Q2. Alright? Okay, so let's find out. Q1 is Q equal to CV. This one also Q equal to CV. What you have to do is you just put this, since this is Q1, so this one must be C1, this must be V1, this one is Q2, so this must be C2, this must be V2. Understand? So Q1 equal to C1 V1, Q2 equal to C2 V2. Alright? So let's find out the answer. Alright? Okay. So where's my C1? Do I have my C1? Yes, C1 is 2 microfarad. C1 is 2 microfarad. Okay? 2 microfarad. So I just put 2 microfarad and my voltage is 36.9. 36.9. And let's calculate. Yeah, let's calculate. Yeah, 36.9 multiply 2. And my answer is 73.8. 73.8. Is it 73.8 coulomb? Is it 73.8 coulomb? Wrong. You forget about the micro here. Our capacitance is microfarad, not just farad. So this one is not coulomb. It is microcoulomb. Okay? It's microcoulomb. It's not coulomb. Okay? Okay, I got the answer already, this one. And then how about Q2? Q2 is, I need the C2. Where is the C2? C2 is 4 microfarad. 4 microfarad. So I put in the 4. Okay, 4 micro here. And the voltage is also 36.9. Okay, let's calculate. Yeah, let's calculate 36.9 multiply 4 micro farad. So I got 147.6 microcoulomb. Why not coulomb? Why not just coulomb? Why got micro? Because the farad got microfarad. So this one microcoulomb. Okay. Another thing is just now I did work out that. I did work out this one. You see Q1 plus Q2 is 221.4 microcoulomb. Is that true? Is that the Q1 plus Q2 equal to 221.4? Try and add up. You try add up this Q1 and Q2. You try add up these two. Do you think you will get 221.4? You plus together this one. If you plus this Q1 plus Q2, you plus this Q1 plus Q2. Yeah, you plus the, you know, these two, that means 73.8 plus 147.6. You plus them together and see. Try and plus it up. Yes, you get 221.4 microcoulomb exactly. You get back this value. You see that? That's the wonder of it. You get back the 221.4 microcoulomb. So that means what you got here should be correct. Your answer should be correct. Your answer should be correct. So am I correct? Am I correct? 73.8 Q1 is 73.8 something the value. Yeah, 73.8. Because this one changed to coulomb already. My one is still microcoulomb. This one is in coulomb. Never mind, never mind. So my answer is still correct. My answer is still correct. 73.8. Yes, is 73.8, correct. And then this is 147.6. 148. Almost correct lah. So it's still correct. My answer is correct. Okay. So I got the answer already. Now finally, so that's the answer. Q3, Q1, and Q2. Okay, that's how I get the answer. Okay, I always stick to the relationship of charge. If parallel, the charge of plus, but the voltage they are equal. For parallel circuit, the voltage they are equal. Okay, and I always use the Q equal to CV to find all their individual value. Q equal to CV. I want to find the charge. I want to find the voltage. I can just use Q equal to CV for anything. I want to use Q total, C total, V total. I just want to Q12, C12, V12, or I just want to Q1, C1, V1, Q2, C2, V2. I can find any value I want. Okay. Now, talking about potential difference between point A and D. Point A and D. Where is point A and D? Point A and D. Point A and point D. Point A and point D, that means between point here, point A and point D. That means I want to find the voltage between here. The voltage between this one. Voltage between AD. What is voltage between AD? Voltage between AD is actually voltage 1, 2. Do you see that? Okay. So question C. Voltage AD is actually voltage between what? Between C1 and C2, isn't it? Voltage between the C1 and C2. That means it is equal to V12. Equal to V12. Do I have already the V12? Do I have already the V12? Yes, I already got it in the process just now. In the process just now, I already got it. V12 is 36.9. How I get the 36.9? I don't know where I began. So you just look up the history. Look up the history book. So how I got the V12. So the answer is 36.9 volt. 36.9 volt. So the answer is 36.9 volt. Okay. So 36.9, 36.9, 36.9. Okay. So is the answer correct? Yes, it's correct. 36.9, 36.9. That's correct. Okay, that's all for this part of example. And there are many examples to come. So I hope you understand my explanations, and I hope you understand. Please like and subscribe and share to either the ones you love. Okay, see you again in the next video. Bye.